All right, let's talk about piecewise defined functions. So a piecewise defined function is just a function that uses different formulas for different pieces of the domain. So we break the domain into pieces and then just use a different formula for each piece. All right, so in example one, we've got a function that's defined in that way. So we have the domain broken into three pieces. We have, x less than or equal to -2, and we've got another interval between -2 and 3, and then another one for x greater than or equal to 3. Okay, and we get a different formula for each one, and we're just asked to graph it. So let's just take it one piece at a time, and we'll look at the first piece. The first piece just says f of x is equal to 4 for x less than or equal to -2. All right, so here is -2, and so if we just say y is equal to f of x, right, then we can, then we're just going to graph a +4, right? F of x is just a +4, a constant +4 for x less than or equal to -2. Okay, so it keeps going on to the left, and the interval is defined to be less than or equal to -2. So this point is actually included in that piece of the function. Okay, so when x is equal to -2, f of x is equal to 4. Okay, by the definition of this function. All right, so let's go on to the next piece. All right, the next piece is for the interval between -2 and 3, and the function is x squared. So we're just going to take x and square it. All right, now, so -2 to 3. Okay, so I'm going to highlight those. And for that interval, now the endpoints are not included. All right, so -2 is not included, but we can get as close as we want. We can go to, -1.9999999, and we can go, 2.99999. Right, so we can get as close to -2 and 3 as we want to. It's just that that point actually at -2 is not part of the interval. Okay, so, but if we put in -2, right, if we look at that end of the interval, where is x squared? We square it, we get 4. So it actually meets up, that piece of the function meets up with the previous piece. So and then I'm just going to put in different values, and it's just x squared, so I'm just going to take x and square it. And so if I put in -1, I get +1. If I put in 0, I get 0. Put in 1, I get 1. Put in 2, I get 4. And then when I put in 3, I get 9. Now, again, 3 is not included in the interval. So what I'm going to do is I'm going to put an open circle at 3 to indicate that that point is not actually included. And I can get as close as I want to. I can get up to 2.999999999, but I just can't go to 3. All right, so I'm just going to put an open circle to say that that's not included. Now, if it didn't meet up at this other side, it happened to meet up with the other piece of the function. If it did not meet up, I would put an open circle there too. But because it does meet up with that first piece, I'm just going to leave it as a closed circle. Okay, and so now I'm just going to connect those dots to indicate what the function looks like, to graph the function between x equals -2 and 3. Okay, so let's see if there we go. Okay, good enough. All right, so now I've graphed the function over the interval from -2 to 3, and then I just want to go to that last piece of the function for x greater than or equal to 3. And the function is just x. So f of x is just equal to x. So at 3, we're at 3, right? And I'm going to put a closed circle there because that point is included in the function. All right. And then, 4, we're at 4, or 5, we're at 5. Okay, so I can just connect those dots and graph that piece of the function. All right. So that's what the graph looks like. All right, I've graphed each piece individually over the interval that's indicated. And if the point is included, then I use a solid dot. If the point is not included, I use an open circle at that point. So if I wanted to evaluate, for example, f at 3, right? you can see that if I follow, if I'm coming from the from the left hand side, I can get as close to 9 as I want to. I just can't go to 9. And then at x equals 3, the actual value of the function is 3. Okay, so there you go. I'll meet you for the next example.